Hi all, I'm Jerome. I work at Invoice2Go, and I'm going to talk a bit about reactive UIs or stateless UIs, or how to use Rx to build stuff. It's going to be a bit of a kind of the learnings that we had at Invoice2Go, rewriting our app in Kotlin and using Rx to build our UIs. Personally, I've only used Rx in the past at the network layer, and then built all my UIs imperatively. So it was quite some challenges. I also created a demo app. The link is at the end of the slides, which we kind of use as an example throughout the presentation. You can grab it and look at it at the end. It's on GitHub. But first, let's have a look at why we actually want to build UIs in a reactive way. So the first and main reason is managing state imperatively is hard. Like normally when you build your UI, you have all the fields where you store the data and Boolean flags on what is pressed and what should be hide and shown. And every time you update a field, you manually have to propagate, like notify all the pieces of your app to kind of say, hey, I updated this Boolean, you should show this and hide this. And obviously you mess it up sometimes, so then you log out, but there's still a comment form and you can still comment, but there's no user object, it's null, and then everything crashes, or state is like the UI is in a kind of weird state. So managing that is really hard, especially as your app grows more complex. On top of that, when we have all these fields and all these data thingies in our presenters, we have threading that kind of updates those fields from the background, and that's even harder. So what is the solution to all those problems? The solution for us is to kind of model a data flow, a unidirectional data flow. So in the example, we'll look at how we can use like the database and observe the database and then just respond to changes in that. So we kind of want to remove all those fields, like all those states in the UI, and just respond to the data coming from the database directly and not store it anywhere in the middle. But really, we want to actually remove state like everywhere, not even in the UI. So we're going to use RxJava to kind of build like these data pipelines between our database and the UI, and make the UI kind of respond to new data. So it kind of looks like this. It's not a new idea. This is a diagram I stole from foo.js, but you also have like a Redux uses a similar flow. So what we're going to build is a simple kind of to-do application, obviously, because that's what we do if we build an example. It's going to use RxJava 2, and it's going to use Room as the persistence layer. I have like snippets of code on slides. Not all the code is there. If you want to see like the complete thing, just check the GitHub link. So let's start with the beginning. Like the kind of cornerstone of the architecture all revolves around the to-do view. In this case, that's the view kind of interface for that particular screen. And I've kind of divided here in two sections. We have the producers, or kind of the actions that come from the UI. They're all kind of observables exposing a piece of data or just signaling a specific action. So we have the add clicks, which is, if we go back here, you can see there's the add button in the top right. We have our description of our new to-do that we're going to add. You can see that here is the second one. That's an observable of char sequence. And then we have an observable of to-do items if you press the checkbox of one of the existing items in the list. The last item here is the render, and that basically renders the current state to the view. It's just a function that takes a view state object and displays it. It doesn't do anything else. So the view state, in our case, is just a list of to-do items, whatever is stored in the database. And the description is the description of the new to-do that you're entering. So the architecture looks something like this. We have our to-do DAO, which is like a room DAO. We're going to observe that DAO. And the presenter, in this case, I've called it presenter, but it's really, you could call it a view model as well, because it doesn't hold any state. And it basically builds a pipeline to the to-do view. So it takes like all the emissions from the to-do DAO and cans them into the to-do view. At the same time, we're going to observe the to-do view for like all the presses and the typing that we do. And the presenter is going to kind of transform that into a to-do item and store that in the DAO. We're not really going to store anything in the presenter itself. It's just going to observe the view for the actions, and it's going to observe the data store for new to-do items or change to-do items. So the DAO is just a room DAO that looks like this. We have a function all, which returns all to-do items that are currently in the data store. And it exposes a flowable. If you're familiar with or not familiar with RxJava 2, flowable is kind of like observable with back pressure. Back pressure is a big topic. We're not going to tackle that today. But basically, every time something changes in the to-do table, it will emit a new list of to-do items. And then we've got two methods for inserting and updating. So we're going to implement our to-do view. We're just going to do that in an activity. This is basically the presenter boilerplate where we create a presenter and we bind to it in the onResume, which makes it active. And in the onPause, we clear the disposables, which is kind of like all the observable streams that are active. We just terminate them. So that kind of shuts down our presenter. That's the non-interesting stuff. The interesting stuff is the actions. In this case, we use Rx binding from Jake Wharton to kind of expose the observable events from the views. So the add button.clicks, the top one, it just creates an observable of a unit. Every time you tap the add button, it just emits a unit. This is all Kotlin, hence the unit. The description is this text changes observable. And what it does is every time you type one character, it will emit the new current description. So it types a lot of, like it emits a lot of times when you're typing. And then the check to do, it's just a convenience method that I created on the adapter that just emits the to do item that you checked. It doesn't change anything, so you have to do the changes in the presenter. We're kind of going to skip over that because it's, we only have so much space on the slides. And then we have our render method to kind of render the view state. This is normal code that you would expect. We just update the items on the adapter. We notify that the items changed on the adapter. And we update the text on the description field when we have a new one. So here we do something slightly interesting, which is we check the current value of the description before we update it. And this is something you'll run into when you build reactive UIs, is that you're emitting new data to the view. But for instance, with edit text, if the data is the same and you update it, you still kind of lose state. So the edit text has other state as well, for instance, where the position of the caret is state as well. And if we set a new value, it will reset the caret position to the beginning, which is kind of annoying if you type, because then the caret is constantly jumping to the beginning. So in this case, we only want to update the text if it was not as a result of the typing, but because of another result. So we'll look at later how that kind of works. Then let's look at the presenter. So here we're basically subscribing to the to-do DAO. So this observes the current list of to-do items. So you can see the talk, like basically this line here gets the list of to-do items. Then we switch map and we retrieve the current text of the description. And the description is actually coming from the behavior subject, which is on the second line. We'll talk a bit about that later. And then you can see at the bottom of the switch map, we're kind of bundling that together into a view state. And that view state gets emitted to the view. Here in the subscribe, we're basically passing the view.render function. So what you always want to do is kind of have, if possible, just one render method. So you bundle up the entire state of the view and you emit that in one go. Like if you would have multiple render methods and kind of just emit like all the chunks individually, then you get like subtle bugs in your UI where the order of things kind of starts to matter, and then you're showing things and updating things that are not shown, and makes it really unpredictable how your UI behaves. So that's kind of why we always want to have like one state that goes into the UI, and then you can have multiple actions coming out. So let's look at the actions. So here at the top, you can see we're listening for the add clicks. Like the unit of the clicks is not really that interesting. So below that, we're grabbing basically the description and discarding the unit. And then in the subscribe lambda, we create a to-do item that we store in the database. The action of storing a new item in the database, because we're using room, will trigger a new emission from the DAO. So our flowable that is listening for the list of to-dos will get a new list of to-dos. So we're basically getting the update in the UI for free. We don't have to do anything for that. The second thing we're doing in the subscribe is we're clearing the current description. So this is the reason why we're using a behavior subject to store the subscription, or the description, sorry. You can see here at the bottom, we're kind of listening for the description from the view and storing it in this kind of container, which is a subject. And it holds the current value. And every time we need the current value, we read the subject and say, hey, give us the latest version of the description. But when we store a new item, we want to clear the description text field, because otherwise it will just stay there. So that's why we're here emitting kind of a fabricated empty string value to kind of clear the description on the next render iteration. So that's also why we're kind of checking if the description changed in the view itself, because in this case, there's a full string there, and then you get an empty string, and then it just clears it. Does that make sense? So in this case, the purpose of the subject is to combine multiple sources of the description. It's combining like what you type from the view, but also when we want to clear an empty value. So yeah, I basically explained this, like useful if you want to fabricate values in addition to what you're observing. But it's also useful if you need to kind of bridge your reactive stateless flow with a stateful world. So in Android, sometimes you need to implement unsafe instance state and store a value, but that's really hard if you kind of got rid of all the state, right? There's nothing there in your presenter, like how do you get the current description? So then it's useful to kind of capture that description in a subject that kind of sits in the middle of your stream, because then you can kind of grab that value in, say, an unsafe instance state method. And also when you're restoring, you can emit a value into that subject to kind of fabricate the initial value. So expressing your logic in data flows allows you to kind of like observe, and like the whole UI reacts to the changes. And the benefit is because normally you have to write separate code that kind of creates the initial state, and then for every change you kind of have to manually keep on updating and calling the correct methods to kind of keep track of what is happening in UI. But in a reactive UI, the code path that keeps your view up to date and in the correct state is the same code path that kind of initially rendered it. So you kind of get all the updates for free. So also, if you look at subjects, it kind of feels like I had at least a feeling for, oh, it feels like a field. You're creating a field, and it feels like state. But it has a benefit because you can observe the state, and you can build like reactive streams based on a subject. So they're kind of like containers that you can observe and respond to as well. So then when you update the subject, you can also have like parts of the app just update accordingly. And if you have like your logic as Rx streams, you can make threading really easily. You could see in the previous slides where we're just like doing observe on to kind of switch threads. And that becomes like super simple. You don't have to worry about it anymore. It also has a couple of drawbacks. Like obviously this stuff has a bit of a high learning curve compared to imperative programming. RxJava, in my opinion, is not really a framework. A lot of people approach it as a framework and think, oh, it's just a library that I'm just going to include and then I'm done. But it's kind of like a different programming paradigm where you have to kind of let go of the if-else statements and the imperative fields, and kind of everything is a flow, and you kind of have to like think in a different way. Also, because you rely on RxJava operators a lot for your logic in your app, if you have to make a small tweak to the logic, that can have a big impact on your observable chain, especially if they're like really complex. So it's sometimes a lot harder to make trivial changes, where in an imperative app, you would just like tuck in an if-else somewhere and you would be done. So those two things combined makes it like more expensive to write the code. But in my experience, once you've got it out there, most of the time it's more correct. Because you kind of have to think through all the edge cases and everything have to be modeled in this flow, you're kind of much more engaged with the code, and you have covered all the edge cases. Whereas in the if-else statements, it's really hard to kind of stuff up and forget to call something, or have a code path that you kind of did not really think about in your head through all those combinations of if-else statements. Whereas in RxJava, that becomes really explicit. So, well, we've looked at observing tables using Room, which is really cool, and how we attach a reactive UI to that. So once you've attached the UI to the Room database, like you can just have different parts of your app update the database, and you don't have to worry about constantly manually triggering the updates to the UI, which is really useful if you have like a big complex app with a lot of data and a lot of different parts that update it. So in this scenario, also, if we would like plug in a backend system that writes new to-dos, we don't have to worry about when that call is coming in. Like, you just write it to the database, and the database takes care of it. We've also looked at how you handle user input and how you can combine that, and how we can use subjects to kind of code exceptions to the flow. Instead of just raw observing a flow, you can also fabricate values or manipulate them. So I hope this was useful and gives you guys kind of an idea how you can build these things. There's a project on GitHub that I created, which has basically the full sample code of this tiny app. It's by no means bug-free or complete or nice, but it serves as a kind of an example. So,
thank you.
Yeah.